Related rates. In this lesson, we are working on related rates in calculus. In a related rates problem, we are given the rate of change of one quantity and we are asked to find the rate of change of a related quantity. To do this, we find an equation that relates the two quantities and use the chain rule to differentiate both sides of the equation, usually with respect to time. To understand it, let's have a couple of examples. Example 1. If x2 plus y2 equals 20, dx dt equals 4, and x equals 2, find dy dt if y is greater than 0. Y is square root of 20 minus 4, which is 4. This can be found using the given equation and knowing that y is greater than 0. We take the derivative from both sides of the given equation. Derivative of x2 with respect to t is 2x dx dt, chain rule, plus 2y dy dt, derivative of y2 with respect to t, equals 0. We reduce it by 2 and replace the numbers. 2 times 2 plus 4 times dy dt equals 0. Therefore, dy dt equals negative 1. Example 2. Spherical snowball is melting in such a way that its volume is decreasing at a rate of 1 centimeter cubed per minute. At what rate is the radius decreasing? When the radius is 5 centimeters. dv dt is given, negative 1 centimeter cubed per minute. The decrease of volume every minute is negative 1 centimeter cubed. We are looking for rate of change of the radius when radius is 5. V equals 4 over 3 pi r3. The volume of sphere in terms of the radius. We take the derivative from both sides of this equation with respect to time. Derivative of 4 over 3 pi r3 is 4 pi r squared times dr dt using chain rule. We know dv dt is negative 1 and radius is 5. And we are looking for dr dt. dr dt is negative 1 over 100 pi. This means the radius of the snowball is decreasing at a rate of 1 over 100 pi centimeter per minute. Example 3. A man starts walking north at a speed of 1.5 meters per second, and the woman starts at the same point and at the same time walking west at the speed of 2 meters per second. At what rate the distance between them increasing 1 minute later? The man walks north with the speed of 1.5 meters per second. If the distance between the starting point P and the man after t seconds is y, then dy dt is 1.5 meters per second. Similarly, dx dt is 2 meters per second. And if we assume at time t, the distance between them is z. Z2 is x2 plus y2. We are looking for the distance between them, dz dt, when t is 60 seconds. We know after 60 seconds, x is 120, 60 times 2 is 120 meters, and y is 90 meters. If we use Pythagorean theorem we get z equals 150, the distance between them after 1 minute. Let's take the derivative from equation stars, equation that relates the quantities together. 2z dz dt, derivative of z2 with respect to t, equals 2x dx dt plus 2y dy dt. We reduce it by 2. We know z is 150. We are looking for dz dt. We know x is 120 and dx dt is 2. We also know y is 90 and dy dt is 1.5. From here, dz dt would be 240 plus 135 divided by 150, which is 2.5. This means the distance between the man and the woman is increasing at the rate of 2.5 meters per second. Thanks for watching.